Hello everyone, welcome to the 8085 instruction series. In this particular session, we'll study about the stack operation using the push and pop instruction with respect to 8085. So, what is the meaning of push? So, push is a 1 byte instruction. It decrements the stack pointer by 2 and stores the contents of the register pair onto the stack. We'll see this operation by the animation. And we have the pop instruction. It is pop from the stack. So this is a 1 byte instruction. It stores the contents from the stack pointer memory to the register pair and increments the stack pointer by 2. So we will understand this particular operation by using some set of instructions. So here we have the mnemonics, so LXI-SP, LXI-B, and we have written some instructions here. We'll see what happens with these instructions. And then we have the memory contents. So because I have initialized LXI SP as FF, so on the right side we have the memory location where we will store some data, and so this is where our stack starts from. So the rule is that generally that when we want to initialize the stack pointer, it must be from the highest available memory location. So in 8085 the highest available memory location is FF. So let us start with the execution. So before starting, we have this the contents of stack pointer register B, C, D, E, and HL. These are the things we will be using. So with the first instruction LXI SP, the data FF, it gets stored in the stack pointer, and stack pointer also points to that. So this is actually the instruction which initializes stack pointer. So stack pointer gets initialized at FF. The next instruction is LXIB. Now LXIB, as we know, it actually stores the contents 1, 2, 3, 4 into register B and C. So this is actually load register pair. So this 1, 2 stores in B and 3, 4 in C. With LXID, the contents 5, 6, 7, 8 they get stored in register D and E. So 5, 6 get stored in D and 7, 8 in E. So next is LXIH. With LXIH 9876, 98 gets stored in register H and 76 in L. Now we go to the next instruction, that is push B. Now with push B, okay, what happens is that stack pointer decrement. As you can see, stack pointer was at FF, it decremented to FFFE, and the content of register B gets stored in that particular location. So 12 gets stored in that particular location, and then stack point again decrements. Okay, so stack point decrements 2 times. So this is the second time, and the content of the register C, which is the low order register, it gets stored at FFFD. Now let us see what happens with push D. With push D, what happens is that stack pointer decrements and the contents of D get stored in the location which is pointed by stack pointer. So 5, 6 gets stored. The stack point again gets decremented, and the contents of register E, that is 7, 8 gets stored in that particular location which is pointed by the stack pointer. Now let us see what happens with push H. With push H, the stack pointer decrements and the contents of H are stored in that particular location. The stack pointer again decrements and the content of L are stored in a particular memory location. So here we get this, and you can see here we are updating the stack pointer also at this point. Okay, now let us see what happens with the pop instruction. Now the first instruction is pop H. Okay, now stack works with the on the principle of last in first out. So the data which goes last, it comes out first. So with pop H, okay, what happens is the content which is pointed by stack pointer, it gets first stored in register L. So this gets stored, so there is no change. The stack pointer increments now, okay, and the contents of the next memory pointer, stack pointer, gets stored at H. So we get this. Okay, so the difference between push and pop in this case is that in case of push, the stack pointer is decremented and store, decrement and then store. In case of pop, it first stores, then increments, stores, then increments. So as we can see, the stack pointer is now at FFFB. Okay, so this FFFB, so the stack pointer is there. Now with the next instruction, that is pop B. Okay, now see, we have changed the sequence. We have pushed B, push D, but we have popped in the B and D in reverse order. So that is what I want to say. I want to show that what the data as the stack pointer is 7, 8, and that will be stored in register C. Okay, so I have purposely done this so that we know actually what happens if we pop in a wrong manner. So this is the so what we get would be different of what we had stored. So what will happen, this 7 8 it will go get stored in register C, and stack pointer increments, and the data 5 6 it gets stored in register B. So this is what we get. So in D it was 5 6 7, now it has come to B and C. Okay, now let us see what happens at pop D. So stack pointer increments, and now pop D. So with pop D, the data at FFFD, the stack pointer, it goes to register E. Okay, the stack pointer increments, and the data which is at FFFE, it stores at D. Okay, so and stack pointer increments. So this is how it works. So initially when we save the data, as we can see, we saved 1 2 3 4 register B and C, and 5 6 7 8 in D and E, but they got reversed because we the order in which we popped was different for B and D. Say if we had popped first pop D and pop B, then we would have got the same data. So that's how this particular stack operation is done with respect to push and pop. So that's all for this particular session. Thanks for watching.